Hello! In this video, we're going to talk about the inverse of a function, but it's going to be expanded upon what we learned in part 1, which was just linear equations. So in this one, we're going to talk about specifically nonlinear functions. You can see that you've got a quadratic function, and this quadratic function is highlighted in yellow here, and the parent function is x squared. But if you're going to graph the inverse of that, we use green, you have this red function here, and it's going like out to the sideways instead of going up. And the equation here, if you notice, the x and the y have swapped. Now, I know it's been a little bit of time, but y equals x squared is the same thing as f of x. So if you wanted to find the inverse using the equation, you would just flip-flop the x and the y. So if you look at the equation, all you have to do is change the x and the y, and if the same thing happens on each individual point. So if you looked at a point here, this is point 4, 2. The inverse is going to be located at 2, 4 because you are simply swapping the x and the y coordinate. So if you look at the one on the right, this one is your cubic parent function, which is the blue up coaster kind of design. And then what you would do, instead of doing y equals x to the third, you would have x equals y to the third and solve for y. So that's why you're winding up with a cube root here as the inverse. Now this next section, I'm going to teach you how to figure out if something is called one-to-one. And for you to understand one-to-one, you need to understand what a function is and how to figure out if it's a function. The easiest way to figure out if something is a function is to graph it and see if it passes the vertical line test. Well, if you have a vertical line, let's look at example A. This is a vertical line right here. And you notice if you have a vertical line that exists anywhere on the graph from the left to the right, if your graph hits it, in two or more spots, it is no longer going to be a function anymore. Now, I want to make it clear that over here, it does pass the test because it hits it in that one spot. It doesn't matter if it passes the test on some of it. If it doesn't pass the test all the way starting over here on the left, and you scan all the way to the far right, it has to pass the whole way. So if you look at this one, if you just imagine starting a vertical line over here and you keep going, it's only going to touch that vertical line in one place. So this one does pass the test, and that is considered a function. A circle, it's going to pass the test here, but as soon as it moves past this tangent point right here, it's going to create all of these double intersection points. Not going to be a function. And then this one also is a very, very obvious example. It passes here, but as soon as it touches here, it's got 2, even 3 at some points. Definitely not going to be a function. Now, everything that we've done so far, those are all considered functions, okay? The problem is that when you're trying to figure out whether the inverse is a function, that's where you're going to start getting non-functions. Okay, so just really quickly, I want you to kind of pause the video and I want you to write down whether or not graph number 1, 2, and 3, do they pass the vertical line test? Yes or no? And then when you have all your answers down, unpause it and let's see if you get it right. Okay, so let's look at number 1. Now, if I start drawing a line over here, I know that's just going to keep going in that pattern. You see how it doesn't matter where I scan it, it only hits at that one spot. So yes, this is definitely a function. Okay, look at number 2. So it doesn't really matter where I draw the vertical line. I'm only going to have one point on here. So that is also a yes. Now this graph is a little different. This is like a typical x to the 4th power. It has this W top style to it. But you know what? When you do this, it still passes that vertical line test. So that all of them are going to be functions in this case. So let's talk about our main goal here. We need to figure out if we have a one-to-one function. Something is going to be a one-to-one function if it starts out as a function and it also passes the horizontal line test. So not only does it have to pass the vertical test, it also has to pass the horizontal. So we need to check for horizontal, and we need to make sure that the vertical line was also passed. Okay, so if you look at this one right here, this is a typical cubic. If you want to draw some vertical lines in there, it will work. So the vertical passes in this case. But what about the horizontal? So if you start up here and you keep drawing horizontal lines, do you see how it only hits at that one place? Look at the blue where it hits the orange, one place. So it will pass. If it passes both, it is definitely going to be a function, okay? So if you look at this one, it's going to pass the vertical test. So the vertical test, yes, okay? Here's the problem. If you draw anything past the vertex or above the vertex, it's going to hit in multiple places. So this is not going to pass the horizontal. If it doesn't pass the horizontal, then that means it is not going to be 101 because the inverse is not a function. So the original, yes, but the inverse is not. So the whole point, when you have a function, you need to test to see if it's 1-to-1. If it's 1-to-1, that means the original function and the inverse is also a function. Always graph it, vertical, and then horizontal line test. Okay, so let's do just a little quick quiz for you. Let's look at this W top shape one more time. I want you to see if this is 1-to-1 or not. So you're going to have to check the vertical and the horizontal line test. So pause the video, try to figure it out, and then unpause it. Now, like we said before, any of these vertical lines are going to pass. So this does pass. The original is going to be a function. Let's see if I can do that. Okay. So vertical, good. Now we got to test horizontal. So horizontal is going to go this direction. Okay, so that's just not going to work because look, 1, 2, it hits twice here. It only needs one instance, but there's multiple. Look, it actually hits 4 times here. So there is no way that the horizontal one's going to pass. So is it 1-to-1? No. So what's our takeaway from that? Why do we care if it's 1-to-1? That tells us that the original function is, well, the original equation is a function, but your inverse is not a function. So in the next section, what we're doing is 2 things. We're figuring out whether it's 1-to-1 because we have it graphed, and then we're going to actually find the inverse, okay? So here's what we're going to do. This one, we've already talked about it before, but notice how it's going to pass the vertical. Does it pass the horizontal? Now this one, if you look carefully, if you draw a line right here, that is going to pass. Now it looks like you have a straight line here, but I promise if you zoom in and zoom in and zoom in, nothing is perfectly horizontal about it. So it might look like it would fail it, but it does not. It only hits right here at that one point. So it does pass. It is 1-to-1. That means the inverse is the function. So let's go ahead and actually find the inverse. So I'm going to write down the original function. First thing that we do is we change f of x to y. And then I'm going to change colors as soon as we move to the inverse. So the inverse is when you swap your x and your y variables. And then what you need to do is you want to solve for y. So when you solve for y, remember you want to add and subtract first, and then you want to multiply and divide. There's a lot of 2 steps that are like that. This one is. Okay, so another thing that you need to pay attention to when you are multiplying and dividing, make sure that you divide the entire side. So it's going to be x minus 1 divided by 2 equals y to the third. Now I'm going to leave it just like this, except for I need to get rid of the cube. Hopefully you remember how to get rid of it. We are going to take the cube root. Just like multiplying and dividing, you want to take the cube root of the entire side. So my final answer is going to look very similar to this. Okay, except for I don't want to leave it y. I'm going to change that to f. And it looks like a power of -1. That just means the inverse of f. And then final answer. So if you're trying to work out a short answer problem, it takes longer. If it's multiple choice, you can kind of stop here and look at the choices, but that's how you finish it using a short answer. All right, so next question, we're talking about a square root function here. You see how it's got that starting point. It looks like it's been, pulled and pushed a little bit. It's got a shift to the right 3. But we've just got to figure out, does it pass that horizontal line test? Is it going to be 1-to-1? So it immediately is going to pass vertical. Does it pass horizontal? Yes. So it is 1-to-1. That means I can find a function inverse. So I'm just going to skip this whole step. I'm not going to write f of x. I'm just going to put y. Okay, I'm going to change back to a different color when I swap the x and the y. That is now my inverse equation. I do have to solve for y now. Now, this one's a little bit different. Normally I say go ahead and add and subtract, but I can't add and subtract because this minus 3 is part of a group. See how it's y minus 3 under the square root? So it's kind of like untouchable at the moment. So what you need to do is you need to get rid of this 2 first. Why do I divide by 2 though? I have to divide by 2 because when this is written in front of the radical, it's times. So the inverse would be divide. Okay, so the 2's are going to cancel out. I still can't add the 3 because I need to get rid of the radical. So this is a square root, and the inverse of a square root is to square. We're going to square everything on the left. I'm going to simplify that just a little bit, and I'm going to write x squared over 4 equals y minus 3. So remember, when you square square root, nothing happens except for cancels itself out. Now I'm ready to add 3. I'm running out of room here. So you wind up with x squared over 4 plus 3 equals y. Now, if it's multiple choice, look for that. But if not, we're going to write it in function notation. And that's going to be our final answer. Okay, so on this last one, I do want to talk about something that I didn't mention because it's been a little bit of time, but when you see you have an inverse graphed with the original function, this dotted line right here, this is your line of symmetry, and the line of symmetry has an equation of y equals x. So it is symmetric on this diagonal line. So if you have access to Desmos, and most of the time you do, you can graph the original, graph the inverse, and just see if they're symmetrical along that diagonal line. And you know that they're going to be inverses of each other. Okay, so this one's special. It says find the inverse of f of x equals x squared, but only when the domain is greater than or equal to 0. Well, let's talk about why that is. This is what x squared looks like when it's graphed. This does not pass the horizontal line test. So what they're doing is they're being clever. They're saying, well, if I just kind of take maybe half of it and get rid of it. So what they did is they're only wanting you to graph the right side. Ooh, that doesn't look very... Well, that's better. Anyway, so they're only going to graph that. So you see the blue line right here? It's only half of the parabola. It's the right half. So that does pass the horizontal line test. So if you just remember this little trick that the domain of the original function is going to be equal to the range of the inverse, and that is vice versa here. So just keep that in mind. So the domain here is going to be x greater than or equal to 0, which means that your range, if you notice, is also going to be y greater than or equal to 0. Okay, so we're going to find the inverse. So I'm going to write down y equals x squared, and then I'm going to flip-flop my x and my y variables. To get y by itself, I'm going to take the square root of both sides, and when you take the square root of both sides, you have to take a positive and a negative. But you have to be clever. If the domain is going to be x greater than or equal to 0, that means that your range is going to also have to be positive. So you're going to actually toss out this negative square root of x, which would be down here. So final answer is going to be just positive square root of x, and I'm going to write it in function notation. There we go. And it says that the inverse is, oh, I already wrote it down there. And I did explain that right here in bold as to why we only do the positive of that. So just let me know if you have any questions, and have fun on the practice.